Hello, can you hear me? Good morning. My name is Ajin Cherian, and I have my colleague Shijay Hao with me. And together, we work for Fujitsu, and together we're going to make a presentation on conflict detection and resolution in logical replication. Probably talk about history, how conflicts were handled in Postgres prior to PG15, what changed in PG15, what are the upcoming changes in PG18, and what are the future features in this area. So just to start, a brief introduction on logical replication. I'm sure you know what it is. Basically, logical replication is a method of selective data replication. If you contrast with physical replication, the difference is that you have more granularity. You can pick and choose what is replicated. You can pick and choose what tables are replicated. You can pick and choose what operations are replicated, or within a table, which rows are replicated, which columns are replicated, so that you have that option. You can also choose what kind of format you want the changes converted in. You can choose a plugin. The default plugin in Postgres is PG output. Another thing with logical replication is that you can have direct writes on the node where the replication happens. And also you can have bidirectional replication between nodes and have multiple nodes replicating to one node. And that's what brings up the problem that we're going to talk about, that is handling conflicts when you have multiple nodes replicating. So conflict handling. So I just want to give an example of what a conflict is. You have two nodes, a publisher node and a subscriber node. You have a user writing data into a table on the publisher node, which has a primary key and another column that gets published to all. And before it gets replicated to the other node, suppose on the other node, a user writes a row on the same table with the same primary key. So what would happen when the replication happens? You have an error, and that's because there's a constraint violation. So that's a classical example of what could be a conflict, right? A conflict is basically when an incoming change from the publisher disagrees with the current state of the data on the subscriber. Types of conflicts could be broadly categorized as conflicts during inserts, updates, or deletes. Currently on PG17, only insert conflicts are reported. So how that's changing, I will talk in upcoming slides. So prior to PG15, we weren't handling conflicts very well. One major problem was that whenever there's a conflict, the apply worker actually gives an error, exits, and it's restarted. And then it again tries to apply that same change. There's an error again, and it exits again. So there's an error loop that happens when the conflicts. It's not very ideal. Update and delete conflicts are not reported and are silently skipped. Conflict avoidance has to be done either manually or writing triggers. There is an API called PG Replication Origin Advance, which could be used to advance past conflicting transactions. But it was a bit tough to use because the operator need to know what the finished LSN of the conflicting transaction was. So without that, it was difficult. I mean, you could use PG Valdum to find that out, but that is not so easy. So that was. And another major problem was minimal information in the error log message. So there's no information of what was the actual error in the log message. So we've made some improvements in PG15. One major improvement was having an option while creating the subscription, that is to disable on error. So now when you have this option enabled, the subscription actually is disabled when there's an error. It doesn't go in that continuous error loop. So you have that option. Second option is an alter subscription command. You could actually use alter subscription skip LSN, which would actually skip a particular LSN when the subscription is re-enabled. So that was one way. And another one is a major improvement is improving the error logs. So right now, new information such as the origin or the node ID from which the conflict originated, as well as the finish LSN of the conflicting transaction is now logged in the error message. So that was the improvement. New system view, PG stat, subscription stats was introduced, which actually showed counts for error counts. There are two types of error counts that are happening while the apply stage, as well as error counts during the sync stage. That's when the initial table is synced, error counts there. So you have two error counts, as well as the stats reset time. That's when the errors actually reset. So with the new options, you could use PG replication origin advanced to advance past failed transactions. Also use the skip command. So I'm going to show you an example of how this is done using just an example. So suppose you have on the publisher node, you have a table tab with one row pre-inserted. So you have that value 5 that's pre-inserted. On the subscriber, you have the same table, but a small difference. The table on the publication does not have a constraint, but on the subscriber, it has a unique constraint. So that's another flexible thing about logical replication. The tables on the publisher and the subscriber need not be identical. It just needs to be the subscriber needs to have a superset of all the columns on the publisher. It need not be identical. So you have a table which has a unique constraint on the subscriber, and you create the subscription with the disable on error configuration enabled. So you start it. You execute 3 transactions. Transaction 1 inserts just one value 1. Transaction 2 inputs values 2 to 8 in 3 inserts, and transaction 3 inserts value 9. So if you had noticed, the table actually started with the value of 5, and you have 5 being inserted as part of transaction 2 again. This is not a problem on the publisher because there's no unique constraint on the publisher. So this doesn't cause an error on the publisher. But you could imagine that on the subscriber, there's actually a unique constraint, and this would result in an error. So on the subscriber side, you see that the subscription is not enabled because it got the error. It's configured to be disabled on error, and the replication is stopped. You just have the first transaction that's replicated, which had 1 in it, and the initial sync value, which is 5. So the subscription is disabled, and the data is incomplete, right? So how do you recover from this? So yeah, let's look at the error message that showed. So the error message shows that there's a key ID 5 that already exists. And also it mentions what is the origin that caused the conflict, as well as the finish LSN of the transaction that caused the conflict. So that's 2 new information that is added in PG15 that we now know. And that is what is used by the API PG replication origin advance. It takes 2 values. One is the origin, and one is the LSN. So what you do is you use whatever the LSN was showing up in the error log, you add 1 to it, and use that as the LSN in the advance API. So and then you alter the subscription to enable it. The subscription was disabled. You advance past and enable. It actually continues past the failed transaction, which is 2, and applies transaction 3, which had just one value 9. So you see all the other values in transaction 2 got skipped. It is just transaction 3 that got applied. So you'll see 5, 1, and 9, right? So that's what happened. You could use the same, you could do the same thing with the command alter subscription skip. Similarly, disable transaction, you use alter subscription skip. Using the same LSN, you don't have to do a +1 there because it's the same LSN that needs to be skipped, and you get the same result. There are other ways of handling such conflicts. You could have a before insert trigger that actually searches for such conflicts and skips inserts. Or you could manually clear the offending tuple. There are a lot of cons for these conflict avoidance methods, like skipping transactions can result in loss of non-offending data. It requires constant monitoring the logs to see when conflicts occurs. There's an operator learning time to understand all these new APIs and stuff. And if you use before insert triggers, that can have a performance impact because it's been done on every insert in the replication. So that's a performance impact. And manually removing tuples that can result in errors and data loss. So there's a lot of shortcomings in the current ways. So we've had some enhancements in PG18. One major enhancement that we made in PG18 was introducing new conflicts, right? So the new conflicts, the insert exists and update exists are pretty much similar to what is already there. But now we have few new conflicts like update origin differs, update missing, delete origin differs, delete missing, and multiple unique conflicts. I'll explain what these are in the upcoming slides, but we have 7 new types of conflicts, and most of them have improved logging. Yep. So insert exists and update exists are very similar to what's already there. It's when an updating or inserting a row while it's a non-differable unique constraint. Outcome is there's an error is raised. It's the same behavior as earlier, but then there's new logs. So the logs have been improved again. So there's a GUC parameter called track commit timestamp, which actually stores the commit timestamp as well as the origin ID of each transaction. So if you have that enabled, then you actually see more information in the logs. Like you see the existing local tuple and the remote tuple that resulted in the conflict. That's there in the error message now. You also know what the transaction timestamp is. Yeah, so more details in the error messages. You have a conflict type, insert exists, that's been added. Okay, so this is a totally new kind of conflict. So far on Postgres, conflicts were treated as constraint violations. Only constraint violations were treated as conflicts. But if you think about it, not only constraint violations are conflicts, right? Conflicts could be, suppose on node A, you insert a row, and node B comes in, updates that row, right? There need not be an actual constraint violation, but that could potentially be a conflict, because is that desirable or not? I mean, that could potentially be a conflict. So how do you handle such things, right? For that, there's you need to make sure that the row that's being updated was not previously inserted or updated by another row, right? So there's a difference in the origin that initiated that row. So for that, there's this GUC parameter called track commit timestamp, which actually stores both the origin where this transaction was originated from, and using that, we could find out whether the row that's been updated was previously updated by a different node. And if that is the case, although the transaction is applied, the update or the delete is actually applied, but a message is logged, right? It's not silent anymore. The operator knows that there's a potential for a conflict there. So the behavior does not change. It's the update or delete is applied regardless of the origin of the local row, but there's a log now, right? It's not an error log, it's just a log, info log, right? So that's a new conflict. Similarly, there's something called update missing and delete missing. That's when you have an update operation or a delete operation on a row that does not exist on the subscriber. So earlier it was silently skipped, but now it's skipped, but it's not silent. There's a log that actually describes that such a conflict has occurred. Finally, this another one called multiple unique conflicts. That's when this any update or insert could result in multiple conflicts, right, on multiple rows. So multiple unique conflicts, we've classified one kind of thing to handle all multiple conflicts happening together on a single operation. So that's called the multiple unique conflicts. So yeah. So if there's a conflict of multiple rows, each row's local tuple and remote tuple are updated in the log. So your information for each of the rows that caused the conflict. So so all of this, you need this timestamp, track commit timestamp GUC to be enabled. Only then you get this much information. So that was all in PG18. So there's more stuff that's under development for PG19 and future versions. I'll hand it over to my colleague, Shishi, to continue on that. Thank you.
Okay, first, thanks Adrian for the presentation on the logical replication conflicts and some existing features to resolve the conflict. And now I'm going to introduce some upcoming enhancements for detecting and resolving conflicts. So first, in the future version, we may have a new conflict called update deleted. So it's a new conflict arrays when the local tuple to be updated was deleted. It's different from the update missing we mentioned earlier because it does not target for the case when the insert has not been applied. It only targets for the second one when the local tuple was deleted, mostly by another origin or by the local user. And here is how it works. So when the logical replication apply worker applies a remote update from the publisher, so it first tries to search the local tuple to update. So if it can find the local tuple, there's no conflict at all, so everything is okay. But if it cannot find the local tuple, it will perform some extra scan to locate the recently deleted tuple, matching the old value from the remote update. So if it found this dead tuple, it will report the new conflict update deleted. If not found, it will report the existing conflict update missing. And here is how the new log looks like. So it logs when the tuple was deleted and logs the other origin and the transactions that were responsible for deleting that tuple. And now people may ask why we need to introduce this new conflict instead of relying on the single update missing. So basically, detecting this new conflict is important for achieving the eventual data consistency in a bi-directional cluster. It's also helpful in one directional cluster, but here we're taking the bi-directional cluster as an example. So as shown in the diagram, say in this case, if a user deletes a row on node B and concurrently another user updates the same row on node A, so in step 3, when it tries to replicate the update from node A to node B, right? The apply worker will find a conflict because it cannot find the local row to be updated, right? So in this case, if we user want to achieve the data consistency, and we assume that we user choose the time-based resolution, like they want to keep the changes with the latest timestamp. So it is also known as the last update win strategy, a simple resolution strategy. And so when applying the remote update, there are two cases to resolve the conflict. In case 1, if the remote update occurs earlier than the local deletion, the update on node B should be skipped, right? Because we want to keep the latest change, right? But in another case, in case 2, if the remote update occurs later, so we need to apply that update. So basically, we convert update into an insert and insert it into node B. So this indicates that without detecting the update delete conflict and gathering information about data tuples, user could not choose, may not choose the appropriate resolution method to achieve the data consistency. And where we can perform an extra scan to locate the data tuples, but the data tuples could be removed by vacuum at any time. So to detect the new conflict consistently and correctly, we also need to introduce some mechanism to retain the data both when it's still useful for the conflict detection. So to achieve that, we have a new subscription option, retain conflict info on and off. So it allows user to specify whether the data post on the subscriber should be retained for detecting conflicts. And people may ask how long should the data post be retained, because we cannot retain the data post forever. It will affect the performance and increase the storage size. So basically, our idea is the data posts are retained before applying and flashing all the remote transactions that occurred concurrently with the local delete. We think this is sufficient to ensure the data consistency when using a time-based resolution method, as I mentioned earlier, such as the last update win or the oldest update win. If we using such time-based resolution method, and if no data posts are found, so it means the local delete happened before the update. So users are aware of which change happens later, which change happens earlier. So user should be able to choose the correct resolution method. Like if you want to retain the latest change, you can convert the update into the insert and apply it. Otherwise, you just keep the oldest change and simply ignore the remote update. And here is how the implementation looks like. So in general, we create a replication slot to retain the data post, and periodically advance the slot X means to allow the unnecessary data post to be removed by vacuum. And as shown in the diagram, right, the logical launcher in step 1 will create a replication slot, and then if someone delete a row in the backend, then till now the tuple deleted by this backend is still non-removable, so the apply worker can refer to it. And apply worker will periodically choose the new candidate non-removable transaction ID, but it does not directly advance it to the slot. Before advancing, it will first request the wall sender to reply the latest wall write position and the information about transaction are in commit phase. This step is used to achieve the concept I mentioned earlier, like the data post should be retained before applying and flashing all the concurrent transactions. So in this example, in step 3, it request, it found that there is a running transaction on publisher and it is committing. So in step 4, it cannot directly advance. It needs to wait for this running transaction to finish. So it requests again in step 5. In step 6, it finally, no transaction is running on the publisher, and it has get the latest war position from publisher. So it has to what needs to be done is the apply worker will wait for all the changes till this latest war position to be applied on the subscriber, and then after all the change has been applied, it will finally advance the slot X min to the value we got in step 2. So this mechanism is to ensure that the concept I just repeated, like all the remote and concurrent transaction has been applied locally. But we know that we cannot retain the data post forever, so we have the mechanism to periodically advance the slot X min, but sometimes it could cause excessive accumulation of data posts if the apply worker cannot catch up with the publisher workload, right? Because basically it needs the apply worker needs to wait for the transaction to be applied before advancing. So if there is a lot of transaction happens on publisher, it will takes a long time, right? So the data pool could be a lot. So and in which case it will affect the performance. So to avoid this risk, we also provide a GUC to allow the data post to be removed. So if the apply worker does not process transaction fast enough to advance the slot xmin within the configured time, the replication slot will be invalidated to allow the database to be removed. Okay, so that's all for the new conflict update deleted. So let's move beyond this new conflict. We also have another feature called automatic conflict resolution, which is also under development. So let's discuss this as well. So it's a mechanism to automatically resolve conflicts depending on the configurations and the detected conflict type. It also provides some built-in conflict resolution methods to save the user effort. And users can easily select the appropriate resolution method for each conflict type. And it can also be used to achieve the eventual consistency in a bidirectional replication cluster. And here is how it can be used. So we provide some DDRs. The user can specify the built-in resolution method for each conflict type in the subscription DDR, like the create subscription, actual subscription, and we use a map conflict type 1 equal to a resolver. You can choose different resolver for different conflict type. And if you do not choose any resolution method, so by default, we will keep the behavior consistent when it's the released Postgre version when a conflict occurs. And next here is all the built-in resolution methods. Let's see, and the resolver is the name of the method, the description, and which conflict can be resolved by this resolver. The first one is apply remote, which means the remote change is applied and apply or skipped. So this is a bit complicated. It means remote change is converted to insert and is applied. But if the complete row cannot be constructed from the info provided by the publisher, then this change is skipped. This is possible because we do not always send all the row information from the publisher. Sometimes if a column value is not changed, we just don't send that information. And in that case, we could not convert our update into an insert. So that's why we need this method. And apply all error is similar to above, but it will report an error if it cannot convert. And keep local means the local version of row is retained. And some other methods are last update win, which is used to achieve a date consistency and keep the change with later commit timestamp. And skip, which means the remote change is always skipped. And error, which means we will report an error for all the conflicts. And the apply worker will keep restarting, so user need to manually resolve it in this case. So taking the last update win as an example, let's see how it resolves the insert exist conflict. So as shown in the diagram, in the logical replication apply worker, before applying the remote insert, the apply worker checks if any conflicting tuple with the same key exists. So if the conflicting tuple exists, the apply worker gets a commit timestamp from the commit timestamp module when this juice is enabled. So, and then it will compare the commit timestamp of the local tuple with the remote insert. So if the conflicting tuple's commit timestamp is later than the remote one, the remote insert is skipped. Otherwise, it creates an update to change the value of the conflicting tuple to match the remote new value. And apart from the automatic usage, this feature can also be used as a semi-automatic tool. For example, initially, user can specify the error as the resolution method for all the conflicts. So the apply worker will keep reporting error for any conflict. So in this case, if apply worker reports an error when applying a transaction because of one of the insert, So in this case, user want to check it by themselves and confirm if this row can be skipped. And after confirming, it finds it can. So it can execute this iter subscription command to now change the resolution method of this insert exist to keep local. And then the apply worker noticed that and will simply skip this insert. But it will still apply the original transaction, but only skip the single insert. So this is useful for the user who want to confirm the rows or date before resolving the conflict. And compared to the existing iter subscription skip command, the difference is this new usage can skip a single change instead of skipping the entire transaction. Yeah, that's all for the features are under development. And we also have some plans for more features, but it's still under design. And one of them is the delta resolution. So it's useful when a balancing account getting credit or debited at two different nodes. So as shown in the diagram, for example, if we have a column store a money number, if a user in node B updates the column from $100 to $300, where another user updates the node A's number from $100 to $200. If we simply use the time-based resolution, the final result will be either the $200 or $300. But in the real world, in this case, people may want to add the difference of the updates instead of choosing one of them. So like this, so people may want to update the balance to the current one plus the incremental. So the final expected result should be $400. So this new resolution method is to handle this case. So the complete can be resolved by adding the difference between the new and old values in the incoming row in the target table. And to offer user more flexibility, we also plan to support the user-defined conflict resolver, in which case user can define a user function. A user can write their own codes to resolve conflicts according to their rules. So user can use their own resolution method. And to enhance the conflict monitoring, we also plan to add a detection and resolution history table. So this table will logs all the detected conflicts along with the resolution method chosen for each one. And of course, we will clean this table regularly to avoid the tuple accumulation. So that's all for the future enhancements. So in summary, in this presentation, we have know that logical replication is a powerful feature that continues to improve and sometimes leads to conflicts. Initially, resolving the conflicts is difficult, but we have keep improving it, and we have more user-friendly and automatic conflict detection and resolution solutions are under development. If you have any question for any of the features or examples, please feel free to send questions to this email. And that's all for the presentation. Yeah, thank you so much for listening. Yeah.
It seems we have plenty of time to questions.
You're talking about the new development, especially, for example, the update deleted. This situation only happening on the two nodes, both can be updated. If one, like a subscriber, is read-only environment, this won't happen, right?
Yeah, if you do not modify the data on subscriber, then this completely will not happen. I think.
So with features like update delete and the focus on there's some bidirectional elements there. Is there any becoming any dependencies between versions where we're replicating across versions? And I was just wondering if there was any modifications over versions to the logical decoding PG update model module for this.
Oh, sorry, can you repeat? Sorry.
So the first thing, is there any dependency across versions introduced when we're replicating across versions of PostgreSQL with some of these changes? Was the first question.
Yeah, this has not been, I think, because this feature is still under development. I think something may be changed. It's still under discussion.
Yeah, so there may be, we're not sure yet. Yeah, okay. And I was just, over time, has PG output logical decoding module had to be changed at all to accommodate some of these changes, or has that been pretty static from early versions?
Oh, yeah.
It's been pretty static, has it?
Yeah.
Okay. Thanks. It has changed. Okay. In that module rather than the workers. Yeah. Okay. Thank you.
I'm just wondering, during development, what steps did you take in order to recreate the problematic conflicts? Like, how did you ensure that you could reasonably and quickly recreate conflicts so well across servers?
Yeah. Actually, in the latest version, maybe you can use like injection points, like to stop the apply worker for a while. Then you do some updating in the remote node, and when it applies, maybe it will create conflicts. But normally we will use debugger or something to create such a conflicts. Yeah.
Okay, so pretty manual.
Yeah, pretty
okay.
manual.
Thank you.
When conflicts are detected, are you, I might have missed it, but are you logging instances of conflicts occurring so people can look at a table later? Or you know, because like in...
we do not log the conflict into a table at this stage, but we have a plan to support this feature.
Okay, and then when I've used other replication tools before, there's been a when you want to handle conflicts, you can remap a table, you know, send the data somewhere else. Is that kind of on the roadmap too?
Yeah, I think we have considered something like that. Yeah, we will do that in the future after all this has been done. Yeah.
Any other questions?
Are those changes apply only for physical replication, or we can use that conflict resolution for logical replication as well?
I think it's only used for logical replication.
Only logical.
Yeah.
And for example, if I have two nodes with two-way replication, and both nodes are heavily inserting data in the same table, for example, before version 18, there is no way for me to resolve those conflicts on primary keys, on inserts. What's the working strategy I should use for that situation?
Maybe like the one Adrian mentioned, like actual subscription skip command. That command.
Yeah, but I need that data, right?
Sorry?
I need, like, I have node A and node B.
Yeah.
And both nodes heavily insert data in table A, for example.
Right.
And because constraints are the same, just primary key, some sort of sequence, right, that generates those primary keys, I will have a lot of conflicts. And there is no way to automatically resolve them. Maybe the only way is to use complex primary key and to include node name in the primary key or something like that.
I think the fundamental problem is that sequences are not replicated. So there is another feature in play where we will be able to replicate sequences as well. So right now, sequences are not replicated. So you don't have a similar sequences on two tables or two nodes. So
a common workaround people do with that is have the sequences increment by different values. So you might have all the odds in one and units together, or you have batches of them. So 1 to a billion here and 1 billion to 2 billion here, and set up your sequences so there's no conflicts.
Yeah, I like that idea about odd numbers. Thank you. Thank you, everyone, and thank you for your presentation. Thank you, Larry.
Is there a way for us to play with this functionality now, or what version do you have to?
Yeah, we
To
have
test
a patch on the hackers. If you can download that and apply to your instance, maybe you can try all these features. Yeah.
Any other questions? I have one question. It's related to when you invalidate the slot that you use. How can you handle the situation when you invalidate the slot? You recreate the slot again?
Yes. This is under discussion, but the current approach is when it finds the apply worker can catch up again, so it will recreate the slot. So apply worker will continue to check if it can catch up now, because we invalidate slot because apply worker cannot catch up, right? So once it can, it will recreate the slot. So yeah.
Okay. Any other questions? Okay. Thank you, guys.